Hello everyone. I wanted to finish up areas in the plane, and so I'm going to focus on numbers 35 through 39. I wrote all the equations down first, but I'm going to go through the sketching of them. I think that's helpful for part of them. I think it's a good idea to pause these videos and try to do the next step or so on your own, and then check the way that I'm completing the problem. So with number 35, what we have is just the part above the x-axis. So when I graph this, I really only have to focus on the upper half of that parabola. It's shifted to the left 3 units, so it looks something like this. And then y equals 2x is like this. Now, if you find that point of intersection, you'll see that it is actually 1, 2. You might not notice that right away, but I think you can see here that if x equals 1, then 1 plus 3 is 4, and 2 squared gives you 4. And also, if x is 1, then y equals 2. So we can be confident that they intersect at this point. Now, I could do this with vertical rectangles, and if I do that, then I can find this area between -3 and the x-axis. But then I would have to find the integral from 0 to 1. And there's nothing wrong with that. But if I use horizontal rectangles, then I can find the length of the rectangle using right minus left, and then integrating from 0 up to 2. And that's the choice I'm going to make. So I'm going to integrate from 0 to 2 because I'm integrating with respect to y. And then I'm going to use the right minus the left. So in order to use the right value, I need to get x by itself. So when I divide by 2 here, I'll get y over 2. This is my right endpoint. And then the left endpoint will be y squared minus 3. So y squared minus 3. And I'm integrating with respect to y. Now, I could plug this into my calculator, but it's also a good idea to be able to do this by hand. So, analytically, I'm sorry. So this would be y over 2 minus y squared plus 3, and I'm integrating with respect to y. So we've done this before. The antiderivative of y would be y squared divided by 2, but there's already 2 here. So that's going to be y squared over 4 minus y cubed over 3 plus 3y. And now I'm going to integrate that with respect, I'm going to integrate from 0 to 2. Now when you plug in 0, you don't get anything. So what we end up getting then is 2 squared over 4, which would be 1, minus 2 cubed over 3, which would be 8/3, and then 3 times 2 gives you 6. And if you do this on a calculator, you'll get 4.3 repeating. Now, if I was going to write that to 3 places, then I would just write that as 4.333, so approximately. For number 36, we have a parabola that is opening downward. It starts off at 4 and comes down like this. And then we have y equals 3x, which is going to go like this. And in number 36, though, we are only interested in the region on or above the x-axis that is bounded by these two. So I'm going to first find the area from this value of x to 0. And then I'm going to find the area here where I'm going to use upper minus lower. So that would be from my x value here. Now, if you plug in a -2, 4 minus -2 squared, you're going to get a y value of 0. So that tells me my x coordinate is -2. So when I integrate from -2 to 0, it will just be 4 minus x squared and integrating with respect to x. But the next one, I need to find this point right here. Okay. Now, if you plug in into both of these equations a value of 1, when x is 1, you get 3. And when you plug in 1 here, you also get 3. So you could find the point of intersection on your calculator, or with a little guesswork, you can tell that it's 1 and 3. So now to find this second area, I'm going to use a vertical rectangle again. So it's going to be upper minus lower. And I'm going to integrate from 0 to 1. So this would be from 0 to 1. My upper function is the parabola, and the lower function is 3x. Now, you can plug that into the calculator, no problem. I'm going to do this analytically. So this would be 4x minus x cubed over 3, going from -2 to 0. And then this would be 4x minus x cubed over 3 minus 3x squared over 2 from 0 to 1. And if you do this calculation, okay, you would end up with 7.5 or 7.5. So if you want to do this, you can plug it in, you'll check, and you'll end up getting with 7.5. Now, this one is not a big deal because when you plug in 1, you're going to get 4 minus 1/3 minus 3/2. And then the 0 plugged in here will give you 0. When you plug it in here, remember you're going to plug in the 0 first, and then you're going to subtract the value when plugging in -2. So just be very careful on your signs. For 37, they say that this is a propeller-shaped region. And what happens is we have x equals y cubed. So y is equal to the cube root of x. And here we have x equals y. So when I graph this, I get a cube root function. It looks like this. And then I have the identity function, which is y is equal to x. Now, my graph isn't perfect here, but these intersect at 0, 0, 1, 1, and also at -1, -1. So when I find the area, I can find the area of this little piece and then add the area of this piece. But my upper and lower functions switch. Here, it's y equals x, and the lower function is the cube root of x. And then here, the upper one is the cube root of x, and the lower is y equals x. But since these two regions are symmetric, I am going to just integrate one of them and then double that. So it's going to be from 0 to 1. Okay, I'm going to integrate from 0 to 1. And then my upper function is the cube root of x. And the lower function is y equals x dx. Now, if you want to plug this into your calculator, that's fine. Again, I'm going to do this analytically. So this turns out to be x to the 1/3. When you add 1, you get 4/3. Divide by 4/3 is the same as multiplying by 3/4 minus x squared over 2. And then we're going to integrate from 0 to 1. Now, I need to double that whole thing here. So I'm going to double it like this. I'm going to find this and then double it. So if you plug this in, you will get 3/4 minus 1/2. So 3/4 minus 1/2 is 1/4. And then when you double it, you will end up with 1/2. Your final answer here turns out to be 1/2. Now, for number 38, if you sketch this, you have a point of discontinuity here at 0. The reason that is you have a vertical asymptote at 0. Okay. Actually, the function is undefined at 0. You have a vertical asymptote. And then you have y equals x. And then you have x equals 2. So here's your line like that. Okay? And we want to find the area right here. Okay? So I'm going to set this up as two integrals. The integral from 0 to 1. And the function is y equals x. So we have x dx. And then we are going to integrate from 1 to 2. Here's x equals 2. That's our right edge. And this time we end up with 1 over x squared dx. So when we find the antiderivative, we're going to get x squared over 2 from 0 to 1. And then the antiderivative of this turns out to be x to the negative 2. So when I find the antiderivative, it's going to be x to the negative 1 over negative 1. So what it basically turns out to be is negative 1 over x. And then we're going to integrate from 1 to 2. Okay? Now, watch your signs here. And when you watch your signs, you should end up then with a final answer here of 1. So you can go through here, and if you have questions, please let me know. Now for number 39, we have two trig functions. We have y equals sine x, and we have y equals cosine x, and the y-axis. So it's going to look like this. Cosine x comes down here. Sine x goes like this. And so, looks like my pen is running out. And we want to find the area right here. Okay? So, sine and cosine intersect at pi over 4. Now, I'm going to write that as 45 degrees here. Okay? But I'm going to use radians. And so now when I integrate, it's going to be from 0 to pi over 4. My upper function, which is cosine, minus my lower, which is sine. I'm integrating with respect to x. So now, the antiderivative of cosine is sine. And the antiderivative of sine is negative cosine. We already have the negative here, so this is going to turn out to be plus cosine of x. Okay, this is going to be plus cosine. The derivative of sine is cosine. Derivative of cosine is minus sine. And now we're going to integrate from 0 to pi over 4. Now, this is going to be sine of pi over 4 minus the sine of 0 plus the cosine of pi over 4 minus the cosine of 0. And now we've got to be very careful. When we're dealing with trig functions, we can't just assume when you plug in 0, you're going to end up with a 0 value. The sine of pi over 2 is root 2 over 2 minus 0. This is root 2 over 2. And then the cosine of 0 is 1. Now, if I combine these two together, I'll get 2 root 2 over 2, which is root 2, minus 1. Now, this would be an exact value. If you did that with a calculator, then you would end up with the square root of 2 minus 1, that would be approximately 0.414. So here's my exact answer. Here's my approximate answer.